Okay, what I have is reassessment number 8. This is on work and potential energy. What I did is I worked a practice problem from the book. And what we have is we have a dart gun, and it has a spring constant of 400 newtons per meter. And what it is, it's compressed to 8 centimeters. The dart itself has a mass of 20 grams, and what we're looking for is what this we want to find the speed of the muzzle dart, but only after the spring has been released to 4 centimeters. So right here I just have our spring constant. The compressed spring is 8 centimeters, the mass, and we're looking for what the muzzle speed is when the spring is at 4 centimeters. So ignoring friction, we get the mechanical energy constant as the initial kinetic energy plus the elastic potential energy in the initial elastic potential energy in the spring equals the final kinetic energy plus the final elastic potential energy in the spring. Because we know, and what I did is I wrote it out in terms. So kinetic energy we know is one half mass times volume, and we know that the elastic potential energy is one half times the spring constant and whatever your initial x is. Since we know that the spring starts at rest, we can go ahead and cancel out the mass of the initial velocity is 0. So what we get is 1/2 kx initial squared equals to 1/2 mass times volume final plus 1/2 spring constant with the final position. What we're searching for is the final velocity. So what I did is I subtracted 1/2 kx final squared, and then I'm taking the square root of the spring constant over the mass times the initial compressed spring. So what you have is the square root of 400 divided by 0.02 kilograms, so the mass of the dart, multiply it by the original compressed spring, which is 0.08 meters, and then we get just over a little over 11. I went ahead and rounded that out, and then we subtract 1/2 times the spring constant times the final amount of the spring, compressed spring, which comes out to be 0.04 meters. And then so we subtract 11 minus 1.8, and we get that the velocity of the dart after being stuck in the muzzle comes out to be 9.7 meters per second squared. Like I said, this is a reassessment for the 8th assessment, which was on work and potential energy.